Hello, algebra students, advanced algebra, and graphing inequalities on a coordinate plane. The last couple of days, we worked on graphing just inequalities in one variable on number lines, and today we're really going to look at how do we graph linear inequalities in two variables, similar to like y equals mx plus b, those types of linear inequalities. How can we verify that the graph is correct? By maybe substituting in a possible solution. And how do we explain where the solution set in the inequality lies? That deals with something called shading. So by the end of this video and by the end of our lesson today and tomorrow, we should be able to understand those key concepts. Now, solutions, as we've talked about, solutions to an equation, right, just to an equation, are points that are on a specific line. That's only if we have like an equation. Like we talked about x equals 3 and the difference between x is less than 3 and having infinite amounts. So points for an equation represent any number of solutions that are on that line. However, that's not the specific case that we have for inequalities. And one of the questions that you were asked to work on, I think it was Tuesday, was looking at an inequality y is greater than x plus 2 and determining whether or not some of these points are solutions. So 3, 4, if I were to plug that in, 4 greater than 3 plus 1, right, that gives me 4 is greater than 4. So we're going to say that's a false statement, right? That does not work. It's a false statement. If I plug in negative 5, 2, 2 for the y, negative 5 plus 1, that's definitely a true statement because 2 is greater than negative 4. All right, so that's a true statement. If we check to negative 4, we're going to get negative 4 greater than 2 plus 1. That's another false statement. All right, so you can see that I have two false statements and one true, meaning these two do not satisfy the inequality. They're not part of the solution set where negative 5, 2 is. If we were to graph this equation, though, and let me outline graphing this in red, okay? We always start, it's almost in the form of y equals mx plus b. And so we always start with our y-intercept, which is 1. Y-intercept is 1. So I'm going to plot my y-intercept of 1 right there on the graph. And then the slope, the number here in front of x, is 1, or 1 up and 1 to the right. 1 up, 1 to the right, 1 up and 1 to the right, okay? And so we get this line in a sense. Now, one of the things that we haven't talked about quite yet is that in this case, I'm actually going to have a dashed line through all of these because if you look, the point 3, 4, right? We tested 3, 4. 3 to the right, 4 up. Right here, we said that was a false statement. It wasn't part of the solution set. So I need an open circle or a dashed line to show that it's not part of the solution set. And then if I look at the other 2 points, right? Negative 5, 2. Negative 5 and up 2. Over here, we said this is a solution where 2, negative 4 is not part of the solution. Okay, they are not underneath, but they are above. So circle the phrase that would represent where the solutions are. In this case, any solution, any point above this line, if we plug it into that inequality, is definitely going to work. Let's just look, negative 2, 4. Let's try negative 2, 4. So 4 for the y, negative 2 for the x. 4 greater than negative 1, a true statement. Anything that you try above this line in this case is going to be part of the solution set. All right, and that's what the activity yesterday in Desmos was also asking you to do, to try and figure out how you might change the inequality to help us shade, okay? Help us shade. So for example, if I were to shade where all of the answers exist, a dashed line and everything up above, right? So I would shade in everything up here just to show that all of these points up above the line, or maybe to the left of it, are part of the solution set. And that's what shading does. So as we're trying to solve linear inequalities, right? Linear inequalities in two variables, there's two things that need to happen. We need to shade either above or left of the line typically, or below and to the right of it. All right, either way. All right, now typically it's when we have these, but that's not always the case. We just have to figure out where the variable is. But there's a way to always test, and we're going to talk about how to test a point to figure out how to shade. The second key is that you have to know what type of line to use. This separates the solutions from the non-solutions, right? We used a dashed line here because one of the points on that line didn't work. 3, 4 was not part of the solution. So I have to say that everything on that line is not a solution, but anything right up to it is. And so we use a dashed line if we don't have an equal to bar, or we use a solid line if we have the equal to bar, meaning all of those points are included. Okay, so we have to think about what type of line to use and where do I shade. And that's what yesterday's Desmo was trying to help you figure out by using different inequality signs to see how many dots you could get shaded in purple. But let's look and see what does this look like in an example, right? Let's try and graph this inequality. Y is greater than negative 3x plus 5. Step 1, what's the y-intercept? Hopefully you said the y-intercept is 5. So 1, 2, 3, 4, 5, right here. Let's just write that out. Y-intercept is the point 0, 5, or 5 up. Now we got to use the slope, which is negative 3, or negative 3 over 1, which in this case means down 1 unit for every 1 unit to the right. So from my y-intercept, I'm going to go down 1, 2, 3, and 1 unit to the right, down 1, 2, 3, and 1 unit to the right, and we can keep following that pattern on and on and on. Okay, so now we have to make a line, but I'm going to think about, before I make that line, what type of line. Notice there's no equal to bar, so in this case, it's going to be a dashed line. I'm going to make it as best as I can. Again, I'm on a mouse, so not a perfect line, but we get the picture here, right? All right, so we get that picture. Then we've got a dashed line. We need to figure out which side of this line to shade. We can do that by picking any point. In this case, they're asking us, is this point, negative 2, negative 3, a solution? Let me know. What do you think? Is it a solution? If we plug that in, negative 3 greater than negative 3 times negative 2 plus 5. Negative 3 times negative 2 is 6. 6 plus 5 gives me 11. So 11 is negative 3 greater than 11. Is that a true statement? This is false. So if I go to that point, negative 2, 1, 2, 3, negative 3, right there, that point did not work. So I can't shade that region, right? I don't want that point as part of my solution set. Therefore, I need to shade everything on the other side of the line in this case, because the point we tested was not part of the solutions. If it was, if this was true, then I would have shaded that side, right? So we can test any point. We pick a point as long as it's not on that line to test. Let's try one more. Here's an example. Graph the inequality. Negative 2x plus 5y is less than or equal to 15. Same thing as negative 2, negative 3 as solution. Actually, we're going to change that one in a moment. So let's just cross that out for a second. Well, how do we graph a problem that's negative 2x plus 5y is less than or equal to 15? We certainly can try to get y by itself. I mean, that's one way to do it. It may not always be nice and clean. But remember, we talked about standard form and using x-intercepts and y-intercepts. So the x-intercept here is going to be negative 2x equals 15. All right, we're just going to replace it with an equal sign just to find the intercept. That's all. X equals negative 15 halves, which is negative 7.5. Right, so that's my x-intercept, negative 7.5. 1, 2, 3, 4, 5, 6, 7.5 is like right in there. Y-intercept is to solve the y part, right? We're covering up the x or plugging in 0 for x. So the y-intercept, 5y is 15, gives us y equals 3. So that's our y-intercept, y equals 3. So 1, 2, 3 up. Now, we've got 2 points. We can create our line. What type of line do we need in this example? Hopefully you said a solid line. So let's just graph that solid line. And now we need to pick a point to test, some point. Again, it can't be on the line, but any point. There's usually an easy point to check. I'm going to suggest whenever we can that we check the point 0, 0. Who likes to multiply by 0? I do. Right? What's 0 times anything? 0. So negative 2 times 0. Plus 5 times 0. 0 plus 0 is 0. Is that less than or equal to the 15 on the other side? Is that a true statement? Is 0 less than or equal to 15? You bet. It is true. That means 0, 0, this point right here, is part of the solutions. It worked. So I need to shade everything in that region that 0, 0 is part of. I need to show that all of these points all down here would work. They're part of the solution set. Okay, so you've learned quite a bit in this video, hopefully. 1, we're graphing lines, those linear inequalities. Number 2, we're trying to figure out where all of the solutions are, that shading one side or the other. And number 3, we're trying to figure out what type of line to use. Are the points on that line included or not? Solid versus dashed. Make sure if you have any questions that you reach out to your teacher, let them know what's going on. Otherwise, you got a couple problems to practice, and we'll see you next time. Stay safe.